Welcome back to All This Math. This is Professor Parker. We about to get into some factoring. Factoring is one of my favorite things to do in all the algebra. I just like factoring. It's really all about patterns, recognizing relationships between numbers. Once you learn it, it's not difficult to do once you learn it, once you get the hang of it, So, and also, I got my Father by Nature t-shirt on. So shout out to my children. Shout out to Nasim. Shout out to Asada. Shout out to Kwame. Shout out to my children, since I'm representing fatherhood right now. All right. So we got 375a to the third power minus 24b to the third power. So first glance, when I see this, the first thing that jumps out at me is like, oh, this might be a difference of two cubes. Now, difference of two cubes is a specific type of arrangement in algebra, right? Within an algebraic expression that you can factor in a certain way, right? Just like you got differences of two squares. We call that dots, difference of two squares, right? Perfect trinomial squares. Other quadratic trinomials that you can factor in a certain way, right? This looks like a difference of two cubes because we got something to the third power minus something to the third power. But notice only the a is to the third power and only the b is to the third power. This 3 don't got nothing to do with that 375. This 3 right here, this exponent 3 over here don't got nothing to do with that 24. So I first look at it and I'm like, all right, maybe it's a difference of two cubes. But then I'm like, chill. No, it's not, because 375, that ain't a perfect cube. 24, that ain't a perfect cube, right? But then I think back and I'm like, oh yeah, what you always should do whenever your job is to factor is to try to find a greatest common factor, what we call a GCF. A GCF. Always try to find a greatest common factor. So what we want to do is we want to see if 375 and 24 have a greatest common factor. Notice I'm not worried about A and B. Why? Because A and B don't have a greatest common factor except for one, right? So A and B ain't really in this conversation about finding the greatest common factor. We focused on 375 and 24. Now, off the top of my head, I know what the GCF for these two numbers is, right? I know that it's 3. But let's say you didn't know that it was 3. That's cool. It's cool if you don't know that it's 3. What I suggest you do is just write out all the factor pairs of the numbers. So let's start with 375. When I say factor pairs, I mean every pair of numbers that multiply together to make 375. Every pair of numbers that multiply together to make 24. And then we look for the biggest number that's in both lists. In both lists. Not the biggest number of each list, but the biggest number that shows up in both lists. The biggest or the greatest. And it's common because it's in both lists, and it's a factor because it can be multiplied to make the numbers. That's where the term greatest common factor comes from. So when you're doing math, you got to know the vocabulary. If you don't know the vocabulary, you're going to be lost. So take some time and learn the vocabulary. If you learn the vocabulary, you understand why things are called what they called. That's half the battle right there. That's going to make it a lot easier straight up and down. So with 375, the first factor pair I'm going to do is I'm going to just say 1 and 375. Because I know that 1 times 375 equals 375. And then what I do is I'm going to just go in order. I started at 1, now I'm going to go to 2. I know 2 is not a factor of 375 because 375 is an odd number. It ends in a 5. It's an odd number. Then I go to 3. I know 3 is a factor. You know how I know? Because if I broke this up into 375, I know 3 is a factor of 300. And I know 3 is a factor of 75. So if 3 is a factor of those two numbers, when that big number, that original number is broken up, that means that it's also got to be a factor of the original number. So it's going to be 3 and 125, right? Now, how do I get 125? Because if I break this up into 300 and then into 75, 300 divided by 3 is 100. 75 divided by 3 is 25. I put the 100 with the 25, I get 125. That's how I know it's 3 times 125. Now, 4. What about 4? 4 don't go into 375. I just know that, right? It has to do with similar to the same reason why 2 don't go into 375. And when I say go into, I mean evenly, with no remainders, none of that, right? 5 is a factor because remember, 5 is a factor of any number that ends in 0 or 5. Remember that rule. Write it down in your notebook if you need to. 5 is a factor of any number that ends in 5 or 0. So how many 5s go into 375? I know if I broke it up, 375. I know that 5 goes into 75 15 times, because 5 times 15 is 75. I just know multiplication facts, and you should too. You should memorize multiplication facts, right? But then if I say, okay, 300 though, I know 5 goes into 30 6 times. So if we attach a number 0 on the 30, we get 300. So that means 5 goes into 300 60 times. See, we could play all types of games, and we use all types of tricks, to figure stuff out in math. That's another reason I like about math. Another thing I like about math, like, there's so many tricks, like there's so many like cheat codes and whatnot. It's just like playing video games back in the day when I was a youngin', right? So that's gonna be 60 and that's gonna be 15. So that's 75. So that means we got 5 and 75. 6, 7. What about 6? 6 doesn't work. You know why I know 6 don't work? Because 6 is double of 3. And here go another math trick. There's so many tricks out here, right? So if we double 3, we get 6. So we would have to take half of 125 in order to still get the product of 375. But 125 is an odd number. So you can't get a whole number as half of 125. So that means that 6 is not a factor. What about 7? 7, nah, 7 is not a factor either. How do I know 7 is not a factor? You know how I know? Because if I broke this up into, so I shouldn't just tell you it's not a factor. I should tell you how I know that, right? If I broke this up into 350 and 25, now first of all, why do I break it up into 350 and 25? Where'd I get that number from? I know 7 is a factor of 35. So therefore 7 gotta be a factor of 350. Just put a 0 on the end of 35, right? But 7 is not a factor of 25, the 25 that's left over. So therefore 7 can't be a factor of 375, because it would have to be a factor of each of those numbers that you got when you broke the original number up, right? In order for it to be a factor of the original number. That's just a math rule. That's one of our math tricks, right? What about 8? 8, let me see. 8, no, not 8 neither, because if I break this up into 320 and 55, 8 is not a factor of 55. 8 is a factor of 320. That's why I'm breaking it up into 320, because 8 is a factor of 320, just like 8 is a factor of 32, right? So 8 is a factor of 32, therefore 8 is a factor of 320. But the 55 that's left over, 8 ain't a factor of 55. What about 9? Now, 9, 3 times 3 is 9. So if I could do 125 divided by 3 and get a whole number, that means that 9 would be a factor of 375. But 125 divided by 3 is not a whole number. You know how I know that? Because if I break this up into 120 and 5, 120 over here, 5 over here, 120 can be divided by 3, but 5 that's left over cannot be divided by 3 evenly. Anything could be divided by 3, but you're going to have a remainder. And when we're dealing with factors, we don't want no remainders. If the remainders are involved, then that means the number is not a factor. All right. What about 10? Nope, because it ends in 5. 11, no, it's not going to be 11. I'm assuming it's not 11. How do I know it's not 11? Well, I know that 121, I know 11 times 11 is 121. And if I do 121 times 3, that's 363. And 363, the difference between 363 and 375 is 12, not 11. So 11 is no good. What about 12? 12 is no good neither. You know why? Because if I break this up into 360 and 15, 360 plus 15 is 375. I know 360 is a multiple of 12, right? So 360 is a multiple of 12. 360 and 15, 15 is not a multiple of 12, meaning 12 is not a factor of 15. All right, so 12 is no good. 11 was no good. 13 is no good. You know how I know 13 is no good? Because 390 is a multiple of 13, right? 390 is a multiple of 13. And because 390 is a multiple of 13, the difference between 390 and 375 is 15. 15 is not a multiple of 13. What about 14? We already said 7 was not a factor, so therefore 14 is not a factor. What about 15? 15 is a factor. You know how I know? Because if I break this up into 375, 300 over here, 75 over here, 75 is a multiple of 15 because 15 times 5 is 75. 300 is a multiple because I know 30 is a multiple. 15 times 2 is 30. Therefore, 15 times 20 must be 300. 15 $20 bills is $300. Again, 15 $20 bills is $300. So, this part was taking a little longer than I originally anticipated it would, but I just kind of wanted to be thorough and break it down because I already told you 3 is the GCF for these two, right? But I wanted to show you the process and also show you like some other math tricks in the meantime as well. So 15 and 25. All right, so let's stop right there with the factors of 375. Let's go over to 24. Now, let's say you didn't know all the factors of 24 off the top of your head. So we're going to do, this is a little easier because this is a smaller number this is a considerably smaller number than 375. So we got 1 and 24. We got 2 times 12. We got 3 times 8. We got 4 times 6. Now, it's only one number between 4 and 6, right? Which is 5. And 5 is not a factor of 24. So what's going to happen is if we keep going up, we're going to hit 6. And then we're going to have 6 and 4. But hold up, though. Isn't 6 and 4 the same thing as 4 and 6? And then we're going to go to 8. And we're going to get 8 and 3. But isn't 8 and 3 the same thing as 3 and 8? It is, of course. So now, to find the greatest common factor, you want the biggest number that's in both lists. So we see that 1 is in both lists, right? And we see that 3 is in both lists. 5's over here, not over here. 15 is over here, not over here. 375, 125, 75, 25. So therefore, 3 is the GCF. It's the greatest number, the greatest factor. These are all factors that they have in common. Greatest factor that they have in common. See? That's why it's called a GCF. So now, what do I do with that? I do this. Write your equal sign, write the 3, write a set of parentheses. Now, what goes into parentheses? That's your next question. What goes into parentheses? The quotient when you divide each of these original terms by the GCF. Divide each of the original terms by the GCF. Divide each of the original terms by the GCF. So 375, a to the third divided by 3 is going to be 125, a to the third. And then 24, actually it's negative. Negative 24 divided by 3 is negative 8. But don't forget the b to the third. I don't like that. It looks sloppy. All right, so we got negative a, 8b to the third. All right, so now let's take an inventory of what we have. We have 3, which was our GCF, times the quantity. Don't say parentheses. Don't say that. That's not sophisticated. We don't say parentheses. We say 3 times the quantity. Whenever we have an expression inside parentheses or brackets or braces, we call it a quantity. That's what we call it. We call it a quantity. 3 times the quantity of 125 a to the third minus 8b to the third. Right? Now, what are we going to do with this? This right here is like what I said in the beginning when I first looked at the problem and I was like, yo, is that a difference of 2 cubes? Right? It wasn't in the beginning, but now this is. You know how I know that? Because I know 8 is a perfect cube because I know my perfect cubes. At least from 1 to the third power up to 10 to the third power. I know those by heart. And you should memorize those as well. At least memorize 1 to the third power up to and including 10 to the third power. 125 is a perfect cube. You know why? Because 5 to the third power equals 125. 8 is a perfect cube because 2 to the third power equals 8. All right? So now, this is how you factor when you have the difference or the sum of 2 cubes, right? What we're going to do is we're going to bring this 3 down. The 3 is outside, right? The 3 is outside. It don't got nothing to do with what we about to do, right? It's got something to do with the final answer, but it don't got nothing to do with what we about to get into. So we do 1 binomial and 1 trinomial. 1 binomial and 1 trinomial. Binomials have 2 terms. That's why I got the spaces right here to let you know that you got 2 terms. We're going to put in there. Trinomials have 3 terms. 1, 2, 3. That's why it's called a trinomial. Like a tricycle. Got 3 wheels. right? Like them slingshots. I think slingshots got 3 wheels. But at any rate, question is, what numbers or terms go in these spaces? All right, what goes in this space? The cube root of this first term goes right here. The cube root of this term goes right here. Let's deal with that. The cube root of 125 is 5, because 5 to the third power equals 125. The cube root of a to the third is just a. So we're going to have 5a. Then the cube root of negative, and be careful, that treat it like a negative because there's a minus sign right there. Negative 8b to the third is negative 2b. Negative 2b. So we got minus 2b. Right? Minus 2b. Now, what goes in here in the trinomial? We got to divide, similar to when we found the GCF. We divide the original term by its cube. Original term by, well, its cube root, not its cube. Original term divided by its cube root. So 125 divided by 5 is 25. A to the third divided by a is a squared. Now, what I do when I do these problems usually is I skip the middle term and I do that last. I do the middle term last, right? I'm going to show you why in a minute. Because in order to find the last term, we do the same step that we just did. We got to do something different to find the middle term. So to get the last term, I'm going to do this original term divided by its cube root. So negative 8b cubed divided by negative 2b. What's negative 8 divided by negative 2? Positive 4. What's b cubed divided by b? B squared. So that's going to be plus 4b squared. Now, what goes in here? What goes in here is this. All right, now listen carefully. You take the product of these two terms and then switch the sign. So you do two things. Write this down in your notes. Take the product of these two terms and then switch the sign. So that means 5a times negative 2b. 5a times negative 2b, which is negative 10ab. Because 5 times negative 2 is negative 10. A times b is just ab. So it's negative 10ab. Then switch the sign. It was negative. Switch it to a positive sign. So it's going to become plus 10ab. So this is our final answer. Now, actually, yeah, this is our final answer because when I look at this, I do like to check to make sure this is not a perfect square trinomial, because it's not a perfect square trinomial, and that's something else. That's another type of factoring, right? I got some other videos on the channel specifically about perfect square trinomials. You should check those out. There's a whole playlist just for those. In order to tell if this is a perfect square trinomial, you look at the first term and the last term. You take the square roots of the first and the last term. That gives you 5a and 2b. If I can multiply those together and then double that, whatever that product was, if my result is equal to the middle term, or it's the exact opposite of the middle term, that means this is a perfect square trinomial, and I'll be able to factor it again. But it's not, because look, the square root of 25a squared is just 5a. The square root of 4b squared is just 2b. Square root of 4 is 2, square root of b squared is b, right? Square root of 25 is 5, square root of a squared is a, right? So if I do 5a times 2b, that gives me 10ab already. If I double 10ab, I get 20ab. That's not 20ab. So that means, therefore, this is not a perfect square trinomial, which means this is the final answer. So I know it seemed like a lot. That video got kind of long. We about to hit 20 minutes. It got long because I took so much time trying to put you onto the game about like how to find factors of numbers and how to manipulate numbers when you got large numbers that you're not used to dealing with, how to break numbers up, like, thinking about like, okay, well, how would I know that 6 is not a factor of 375? Well, you could break 375 up into a number that 6 is a factor of, and then whatever's left over, if 6 ain't a factor of that other number, then 6 is not a factor of the original number. For example, just like a recap, 6 is a factor of 360. I could break 375 up into 360 and 15, because 360 plus 15 is 375. So even though 6 is a factor of 360, 6 ain't a factor of 15. So if it's not a factor of both numbers when you break the number up, then that means that it's not a factor of the original number. That's how that works. All right. So this is our final answer, 3. And don't forget about the 3, because 3 was our GCF from the beginning. We got 3 times the quantity, 5a minus 2b, times the quantity, 25a squared plus 10ab plus 4b squared. All right. And that, my friends, is how you factor out a GCF. You start with a binomial, you factor out a GCF, and you factor a difference of 2 cubes. This is a difference of 2 cubes, right? Summing difference of 2 cubes is probably like the last type of factoring that we actually teach. You know, so oftentimes you might not see it in Algebra 1, you might see it in Algebra 2, but you definitely need it. You're going to need it in pre-cal, you're going to need it in calculus, and so on and so forth. So, yeah. Shout out to all the fathers. Shout out to I can't remember the group, but shout out to Matt Pressberry and the group on Facebook that produces these t-shirts, where I got this from. Get some practice and get some more practice with factoring. All right, get some more practice with factoring, algebraic expressions, and I will see you on the next video. Peace.